Bismillahirrahmanirrahim. Assalamu alaikum dear friends. You are watching Study with Sheraz, and in this video we are going to talk about the oxidizing and reducing properties of the elements. Many students find the oxidizing and reducing agents a difficult topic to talk, and if you have same problem, this video is only for you. And many also students that find the electrochemical series and the concepts of electrochemical series very difficult and confusing. So after watching this video, you would be crystal clear about the concepts of the oxidizing and reducing agents and the electrochemical series. So let's start the lecture. Basically, if you are going to talk about the oxidizing and reducing agents, you must be clear that what does these words mean. If we talk about the oxidizing agent, so keep in mind that these are agent, and who is an agent? It's a person who is helping someone else in doing their work. So if we are talking about the reducing agent, so it's an element or a species that is helping someone else or any other species in getting reduced. So if we talk about the reducing agent, let's look at the definition. They can lose electron in aqueous solution. So a reducing agent is something that can lose electron. So it gives its own electrons to someone else or another species to get reduced. So a reducing agent is itself oxidized and it is reducing something else. So it's acting as a reducing agent. So keep in mind that a reducing agent is itself oxidized and is helping something else to get reduced. So they belong to the groups 1, 2, 13 and 14 because these are the elements that are mostly metals, and metals have a tendency to lose their electrons. Metals have a tendency to lose their electrons and they can donate their electron to something else. So they are themselves oxidized and the other species that is accepting the electron would be reduced. So they can act as the reducing agent. If we talk about the reducing power of the elements, so reducing power decreases along a period. When we move from the left to right in a period, the reducing power of the elements goes on decreasing. So elements after group number 14 cannot act as the good reducing agents because they are electronegative and they cannot prefer to lose their electrons. If we talk about the variation of reducing power down the group, so it increases down the group because down the group the size of elements goes on increasing, the ionization energy goes on decreasing. So it becomes more and more easy for element to lose their electrons when we move down the group. So reducing power increases down the group, it decreases from left to right. And if we talk about the reducing power in the form of the reduction potential, you people know that is the symbol of the standard reduction potential. Smaller is the value of the standard reduction potential of an element, greater is its reducing power. Keep in mind this is reduction potential. So if an element has smaller reduction potential, it means that it has less tendency to accept electron. So if it is having less tendency to accept electron, it is having more tendency to lose electron. So the elements that can act as a reducing agent have a very small value of the standard reduction potential, that is represented by the E naught reduction. So the small symbol O or naught shows the standard condition. Next we talk about the oxidizing agent. So oxidizing agent can accept electron from aqueous solution. So an oxidizing agent is helping something else to get oxidized. So if something else is getting oxidized, so it would accept electron from that species and itself it is reduced. And they belong to the groups 15, 16 and 17. So these are the electronegative elements that can accept electron from something else or another element to get that element oxidized, and they are themselves reduced. If we talk about the variation of the oxidizing power in the periodic table, so oxidizing power increases along a period. So its trend is opposite to the trend of the reducing power. So it increases from left to right in a period, but it decreases down the group. So if you know one of the trend, you can manipulate the other trend. Higher the value of the E naught reduction, greater is its oxidizing power. I have explained this term earlier that E naught reduction is the tendency of an element to accept electron. If this value is greater, if this value is higher, so greater would be the oxidizing power of the element. So elements having greater values of the E naught reduction can act as the good oxidizing agents. So next we talk about the electrochemical series. So what is electrochemical series? The concept is very important. It's an arrangement of the elements in increasing order of the E naught reduction values. Electrochemical series is used extensively in the electrochemistry. Elements with the smaller values of the reduction potential are kept higher in the series that are followed by the elements with the greater values of the E naught reduction. If we talk about the electrochemical series, lithium has E naught reduction value of the minus 3.50. So lithium has the smallest value of the E naught reduction in the electrochemical series, and the fluorine F has a highest value, that is 3.85 volt. So E naught reduction values are measured in the volt. So this is volt. It would be also having the unit of the volt. Next we talk about the groups. So elements of the group 1, 2, 13 and 14 have negative E naught reduction values because these are metals, and metals are having least tendency to accept electron. Instead they are having the tendency to lose electron. The groups 15, 16 and 17 elements are having positive values of the reduction potential. You can see here that the lithium is having minus value, that belongs to the group number 1, and fluorine is having positive value, a very large positive value, so it belongs to the group number 17. So group number 1 to 13, 14 elements are having negative values, 15, 16 and 17 are having positive values. So this was all about the oxidizing and reducing powers of elements and their variation in the periodic table. If you have any question related to this video, you can post your question in our comment section. We will meet in the next video. Up till then, Allah Hafiz.